Hello everyone, I'm Karen from MDPI and I will be your host for today. Thank you all for joining our latest MDPI webinar on toxins entitled Evaluating Mycotoxins in Food Safety, Toxic Effects Present in Food and Biomonitoring, Strategies of SDG-Agenda 2030. This is the second webinar on toxins based on special issues from our journal of the same name. And if you are interested in submitting your paper to the special issues that are linked to this webinar, please check the webinar's webpage. I would also like to remind everyone that this webinar is recorded. The recording will be made available as soon as possible. It will be posted on the webinar's webpage. The webinar is also being live streamed on MDPI's YouTube channel. Hello to those of you watching us on there. Furthermore, certificates of attendance are available upon request to toxins.webinar@mdpi.com. We can only prepare certificates for those of you registered and watching on Zoom, not on YouTube. Today's webinar is chaired by Professor Dr. Ana Juan-García, who is an Associate Professor of Toxicology at University of Valencia in the Department of Preventive Medicine, Public Health, Food Science, Toxicology, and Forensic Medicine. She holds a degree in pharmacy and received her European PhD in food science, both by University of Valencia. She was postdoc researcher at Purdue University for 2 years with a Fulbright grant and more recently, visiting scholar at Harvard University. She serves as Purdue Alumni Ambassador in Spain since 2014. Professor Dr. Juan-García focuses most of her research on toxic effects of compounds containment present in food and feed, and more specifically with pesticides, antibiotics, and mycotoxins. To highlight that her research effort is addressed in evaluating mycotoxins toxicity from majorly in vitro, but also in vivo and in silicio assays by using different technique and biological models. All this has brought her to participate in more than 100 posters, presentations, communications at national and international conferences, and to serve as guest editor in special issues. There will be 3 presentations today given by the chair herself and Professor Cristina Juan from University of Valencia in Spain, followed by Dr. Oana Stanciu from University of Medicine and Pharmacy, Cluj-Napoca in Romania, and Dr. Liliana da Silva, University of Coimbra in Portugal. The presentations will be followed by Q&A, moderated by the chair. If you have any questions, please feel free to post them in the Q&A box at the bottom of your screen. Please make also sure to mention the speaker to whom you are asking the question. And now it's time that I hand over the floor to Professor Ana Juan-García. Please enjoy.
Thank you very much, Karen Tisler, for the introduction. Good morning, everyone. Here we are. Okay, so good morning, everyone. So this is the webinar that actually already Karen has introduced, evaluating mycotoxins in food safety, toxic effects present in food and biomonitoring, so strategies in the Sustainable Development Goals, the Agenda 2030. So actually it's going to be the presentations with some hints and to give them some strategies that are involved in the SDG, specifically not in all of them, the 17 SDG, but in few of them. So the presentation that I'm gonna give has the title of In Vitro Toxic Effects of Mycotoxins Alleviated with Bioactive Compounds Present in Food, Some Strategies of Proximity Consumption. So the 2 goals that this presentation is going to deal with are actually out of the 17, with goal number 2, the zero hunger, and goal number 12, which it will consist in the second part of the presentation, which actually is related to the responsible consumption and production. Starting with this first part of the presentation and related with the Sustainable Development Goal number 2, zero hunger, it emphasized to end hunger, achieve food security and improve nutrition and promote sustainable agriculture. These SDG goals have been described and have been related some infographics that actually I'm presented here, but actually the two important ones that are going to be dealing the presentation is providing and ensuring a food security. So there was a food insecurity that was already on the rise, and it has been implemented, let's say, as before COVID, but during COVID-19 implication, the pandemic is an additional threat to food systems. So actually and globally, it is known that 1 in 10 people is undernourished and does not have enough food to meet his or her dietary needs. Undernourishment is most widespread in Sub-Sahara, so Africa, Sub-Saharan Africa, South Asia, and East Asia and Pacific, as reported in this slide. If we go to what are the foods that the population in general, what's the global progress of food consumption according to the FAO, we have this diagram where rice, wheat, other cereals, vegetable oils, sugar, meat, roots, tuber, pulses, and others, that will be the order, not during these years, but also it's an estimation for the 2030, but also it has been increased in these different foods during the years. But if something has to be emphasized is that the base of this food consumption correspond to basically cereals, rice, meat, and other cereals. So food and health is a binomial that correspond and are together, and it's a concern from the society and for the authorities of food consumption, as foods can have present different contaminants that can be pesticides, that can be PAH, that can be metals, that can be different organic contaminants, but one of the important one that we're going to be treated in this presentation and that I'm going to be focused on are mycotoxins. So these food contaminants, with the food authorities englobe and have an umbrella that protects the health for consumers. This protection, which actually it's deal with the food safety, it's not only to protect the strong effects that can appear related to these contaminants, but also to toxic effects more described either acute or in chronic because of the exposure to these contaminants present in food. So what's the importance of mycotoxins? You might know that, or probably know, you might know that mycotoxins are secondary metabolites produced by several fungi, in general Alternaria, Fusarium, and Penicillium in different substrates, either food, which is the focus of the presentation, but also in feed, under specific conditions. Mycotoxins constitute a group of highly toxic compounds. In fact, the International Agency Research of Cancer from the World Health Organization has classified them in group 1, 2A, 2B, or 3, related as carcinogenic to humans, probably carcinogenic, possibly carcinogenic, or not classifiable as carcinogenic because there's a lack in some assays or proofs and correlation for this classification as carcinogenic. And also EFSA is the European Food Safety Authorities has also a great concern with these compounds. In fact, recently the Rapid Alert System for Food and Feed, so more known as RAF, has situated and has reported that out of the total notifications received, a total of 588 were notifications related with mycotoxins. These are the latest data available, and so it's mycotoxins are situated as the second most important food contaminants to take care of and to be aware of. One of the important mycotoxins that is this presentation dealing with and that I'm going to be working is the bilbericin. Bilbericin, it's a mycotoxin which actually has been reported with several toxic effects and also has had associated as an effective antibacterial activities against both pathogenic gram-positive and gram-negative bacteria, has an effective capacity to inhibit the human immunodeficiency virus type 1 integrase, and has the cytotoxicity is mediated through mitochondrial alteration. There is no regulations yet for bilbericin, but EFSA has also has been taken in consideration by reporting scientific opinions relating to the risk to humans and animals because of the presence of bilbericin in food and feed, and also because of an external scientific report has been also published related with the genotoxicity. I would like to say something else about this mycotoxin, and it's classified it was classified as an emergent mycotoxin, and it deals with this complex chemical structure and at cyclohexadeoxypeptide mycotoxin. But at the same time, we not only found for sure contaminants in food, but there's natural compounds in them, with most of them have proved antioxidant capacity, as for instance the presence of carotenoids and polyphenols, which are increasingly proposed to prevent and treat various diseases and for the prevention of toxic effects of contaminants. Research in natural antioxidants has proven to be potential agents for reducing the incidence of various diseases and various types of cancer, as well as the toxicological risks related to various toxins and mycotoxins. And nowadays, dietary chemoprevention is increasingly becoming established as a convenient approach to for the control of several diseases. And it is important to take into account that the base of the food and the diet, most of it is related with cereals. So the presentation, it's gonna be from now on being considered different type of foods, goji berries, coffee beans, and garlic cloves, actually dealing with carotenoids and polyphenols. Garlic cloves have organic sulfur compounds, which actually it's a future perspective that we have, but these foods, which or how do they affect the health, and then how they're gonna be studied either in one of the first steps when food is ingested, which actually is in the absorption. So I'm gonna be presenting some results related with this absorption. What's the effect that can have at cerebral level with cell line, the SHS-YFY, and then also some implication in the metabolization and the leaving aside that's the fact of the accumulation, which actually these compounds can be happening. So dealing with the carotenoids, which actually correspond, or they have high capacity as antioxidant, that could be useful in limiting or preventing some toxic effects of contaminants. That has been reported in the literature, and some of the carotenoids that we can find not only in the goji berries that I'm going to be dealing with, but also in pumpkin, in orange, in tomato, in carrots. So are alpha-carotene, beta-carotene, cryptoxanthin, bioloxanthin, zeaxanthin dipalmitate, and the two main ones present in goji berries, which actually are lutein and zeaxanthin. The total amount of carotenoids present in goji berries is around 306 and 366 milligrams per 100 gram. Goji berries are considered a source of bioactive compounds and also associated to the prevention of several chronic diseases as macular degeneration, diabetes, cancer, etc. The majority of world researchers' phytochemicals evaluation are focused on in knowing the profile of the carotenoids for the goji berries. The intake of antioxidants can present a complete strategy to completely inhibit or at least reduce the toxicity of mycotoxins. So having the effect of these carotenoids, how can we reduce the effect of some mycotoxins, specifically in cytotoxicity? Nonetheless, the researchers outlined the need to study carotenoids bioaccessibility from goji berries. What is known already from lutein and zeaxanthin as the main carotenoids present in goji berries? From lutein, effects against mycotoxins effect related with T2 toxin on chicken hepatocytes, it was demonstrated that there was a cytoprotection when both were combined together and exposed or given to these hepatocytes. Deoxynivalenol in HT29 cells, which actually are cells from the intestine, it was demonstrated that cytoprotection and a reduction of the oxidative stress was observed, and downregulated the expression of two inflammation genes, and also it was demonstrated a prevention of apoptosis. Related with zeaxanthin and also lutein on human colon epithelial cells and HT29, it was demonstrated a decrease in the viability of tumor cells. Starting with what's the methodology that we follow to deal and to use these goji berries to see the effect of the main carotenoids present in the goji berries, it is known that 100 grams of goji berries has approximately 0.005 grams of zeaxanthin and 0.025 of lutein. And so what we did, we get 7 grams of goji berries and we obtain 25 milligrams of dry extract. We mix it, we lyophilize these 7 grams, obtaining 25 milligrams of dry extract. And during the calculation, we knew that lutein and zeaxanthin were in this proportion, which supposed that we were able to expose the cells according to the protocols and the performance and to develop the assays that we were able to expose the cells to 3.08 micromolar and 6.1 micromolar in cells, which actually these values correspond exactly with the physiological levels present in human blood plasma. So the first results present here are going to be with the extract of the goji berries, which is main compounds lutein, zeaxanthin as the carotenoids, which were the effects in the cacutis cells, which are intestinal cells. And what we did, it was the assay of cytotoxicity through the MTT assay, which actually what is happening is that there's a reduction of the tetrasodium salt to formazine blue, denoting that the amount of alive cells is proportional to the amount of formazine blue produced. So we add these reagents to the cells after being exposed either simultaneously or with a pretreatment with the carotenoids and the mycotoxins. after the conditions of 4 hours 37 minutes. So if there's a live cells through the succinate dehydrogenases present in mitochondria, they're going to reduce this salt soluble in insoluble formation blue. So this was performed in the CACO2 cells, as I said, and these were the results that we obtained, which actually with the presence directly with the lutein and zeaxanthin, the viability was above 100%, either at 24 and 48 hours. But however, when we treat those cells with the berbericin, so we have a decrease in viability, which actually we can establish the IC50 around 12.5, more or less, for 48 hours, and a little bit higher for 24 hours. However, when we try to when we assay the goji berry extract directly in these CACO2 cells, what we observed, it was also this good viability, also higher than 100% for 24 and 48 hours. Oops. Okay. When the extract, when the carotenoids, directly the zeaxanthin and lutein, were assigned simultaneously with the mycotoxin, actually, as I said, the berbericin, what we observe here, where we record the berbericin and the lutein at the maximum concentration that will be present in blood after ingesting 7 grams of goji berries, and the presence of berbericin, 25 micromolar, we recorded it's in blue, the effect of berbericin, in red, the effect of lutein, and in green, the effect when both carotenoids, so lutein and berbericin, were treated together in the CACO2 cells. So we can observe that there was a good or an increase and a better result when this happened at 1.5 and 12.5 of beta and lutein. For the zeaxanthin, we were also almost in the same situation with having a good effect or a protection, cytoprotection, with simultaneous treatment also in the second dilution. While when both carotenoids and berbericin were exposed to the CACO2 cells simultaneously, what we saw is that there was different improvements in cytotoxicity for different conditions according to the different concentrations. Another type of doing this assay was to pre-treat the cells with the carotenoids during 24 hours, and afterwards to expose the cells to the mycotoxin, the berbericin. So here are the results, the pre-treatment ones. So when the higher concentration of berbericin was exposed, we see protection also because of that treatment. Similarly, this is happening when assay with the zeaxanthin, and here also when both lutein and zeaxanthin were exposed to the CACO2 cells, pre-treated, and afterwards with the mycotoxin berbericin. So assigning directly the goji berry extract, where the two main carotenoids, lutein and zeaxanthin, are present, but also all the other carotenoids that goji berries have. So when there was a simultaneous treatment, what we saw is that there's this improvement of the viability, and in the pre-treatment, so also we see this good exposure and good protection for the highest concentration of the mycotoxin assay. So cytoprotective effects of zeaxanthin and lutein against berbericin induce cytotoxicity on CACO2 cells. The major capacity to improve the cell's viability was recorded when both zeaxanthin and lutein were used simultaneously. And the cytoprotective effect depends on the concentration of carotenoids or goji berry extras and the bericin present in the food product, as well as the simultaneous presence of zeaxanthin and lutein and the interaction between them. And with these findings, in addition to the fact that the consumption of goji berries is strongly increasing in European countries, it's a food that is being introduced slowly in the diet, suggests that the consumption of goji berries could help to prevent the toxicological risk to humans that they can produce or mitigate the cytotoxicity effects induced by this toxin. Going further with the presentation, we assign the goji berries and these carotenoids in the SHS Wi-Fi white cells, which actually belong to an undifferentiated neuroblastoma cell line, as these cells are able to be working with them differentiated or undifferentiated. We were working with undifferentiated, so they were not neurons. So they were the previous step. So the effects very well correlated with the ones that we saw in the CACO2 cells. They keep a good viability when exposed to these concentrations of 3 and 6 micromolar as the highest concentration that we can test after ingesting 7 grams and after being present in blood plasma detection. And on the other side, for the bericin, at the 2 times exposed, 24 and 48 hours, we see a more sensibility, a higher sensibility from the SHS Wi-Fi Y cells. Regarding the goji berry extract, what we observed, it was also a good viability, higher than 100%. So we see this good viability for the different dilutions of the extract. And once more, we try to see what was the effect of both major carotenoids present in goji berries, lutein and zeaxanthin, simultaneously and pretreated in these SHS Wi-Fi Y cells. For lutein in this side, so we see the same as I mentioned before regarding with the colors, that the green color is providing a slightly a good viability in the this cell line, but it is not overpassing when the cells are exposed only to the carotenoid lutein. Similarly, this is happening for the zeaxanthin, but when both carotenoids are exposed, are treated simultaneously, yes, we do see, at least in some of the cases, better viability, so cytoprotection. In the pretreatment, results are not as good as we were expecting, because actually it seems that there were not protective effect at the highest concentration exposed, but although at very low concentration or very low concentration of the concentration of the bericin, so it's able to have a higher viability. For lutein, not working as well for the zeaxanthin, and when they were pre-treated together, so also the results were not that good. When the goji berry was assay and simultaneous and pre-treatment, only with the goji berry extract, these results were high and were good. It was not possible in the simultaneous treatment to overpass the effect that the bericin is causing itself when it's treated with this mycotoxin, and similarly with the pre-treatment. So what we obtained with this cell line, the SHS Wi-Fi Y cells, with both carotenoids in simultaneous treatment, the highest cytoprotection was above 30%. And with zeaxanthin, it was 24%. In the pretreatment, lutein proved to be the more cytoprotective, around 30%, and than the other combinations as the zeaxanthin or lutein plus zeaxanthin. Regarding with the goji berry extract obtained in simultaneous treatment, there was no cytoprotection, while in the pretreatment, the high cytoprotection was observed to be above 20%. So interaction between lutein, zeaxanthin, and bioberisine by the isobologram method reverse energy interaction. There's a study forward that can be done with these results of cytotoxicity, and it's by treating with the isobologram method, which actually studies the interaction, the type of interaction that can be observed when several compounds and mixture of compounds are present or are exposed to a cell line, and when we also assay that and we observe a synergism effect. So main carotenoids present in goji berry extracts, lutein and zeaxanthin, play an important role in protection observed in both human colorectal adenocarcinoma cell, CACO2 cells, and the SHY cells after exposure to bioberisine. Cytoprotection was associated to the dilution of the goji berry extract. The higher the dilution, the lower the protection. And the recent integration of goji berries in the Mediterranean diet is a very good welcoming tendency, which is giving benefit regarding the potential toxicity of some mycotoxins and for sure in some concentrations as bioberisine, and it also contributes to a safer health and varied diet permission. The second part of the presentation, which actually is going to be shorter, but it's dealing with the SDG number 12. It's goal, Sustainable Development Goal number 12, which is related with the responsible consumption and production to ensure sustainable consumption and production patterns. So the infographics provided by the WHO is the one that you have here in the slide, but the one that in the part that I'm gonna be focused for this SDG is in this part of here, which actually it corresponds to harvesting, transport, storage, processing, and to remark that 13.8% of food is lost in supply chains. So how is it possible to have a step forward in food that we are consuming? What is the use that we can give to some of the waste obtained in some food that we consume? And this is happening, and I'm going to be presenting it for coffee. Coffee beans, which actually are rich in polyphenols. We studied them in the SHS Wi-Fi cells line, and actually remarking and improving and implementing an upcycling method, which actually consists in giving a new use of the waste that we were obtaining after processing or after using the coffee beans. So here I wanted to show you what's the meaning of recycling, what's the meaning of downcycling, and what is happening when we upcycling. So also related with the study in the protection of the mycotoxins, and also with the bioberisine. So, and also emphasizing that the mycotoxins, the effect that they can have in the central nervous system, highlights also the necessity of searching and studying strategies to reduce or eliminate the risk that these mycotoxins can produce in the CNS. So when coffee is processed, once coffee beans are processed, two main coffee byproducts are obtained, which actually are discarded, and these are the silver skin coffee, which actually is involved in the coffee, the coffee bean, and once the coffee is used, is what we obtain is the spent coffee. So nowadays both are classified as upcycling products in the food industry. So we have the silver skin and the spent coffee. The polyphenols present in coffee beans and also in the coffee byproducts are presented here. One of the most important ones is the chlorogenic acid. So what we did, we performed a extraction procedure both from silver skin coffee and spent coffee, and different amounts were extracted with water. We're supposed to have this amount in bain-marie 2 hours and 90 Celsius. Afterwards, it was centrifuged, and afterwards, with the rota vapor, we obtained an extract of the silver skin and an extract of the spent coffee. These extracts were analyzed with the Q-TOF-MS to see which were the amount and the proportion of these polyphenols in the different extracts, and these extracts were afterwards exposed to the SHS Wi-Fi cell line with the same assay that I was presenting in the first part of this presentation, which was the MTT assay, studying the cytotoxicity. So the amount of the total polyphenol contents that were observed in extracts directly obtained and explained in the previous slide were identified by the mass spectrometry LCMS TOF, and what we see is that the concentration in milligrams per grams of these polyphenols in the silver skin, the chlorogenic acid, was higher than in the spent coffee, and lower concentrations were obtained for all the other polyphenols present in this extract. Chlorogenic acid, gallic acid, salicylic acid, vanillic acid, and vanillin were at least a good identified in high concentration. When we assign these extracts, which actually are the boiling water extract, that's how we call this extract, at 24 and 48 hours in the SHS Wi-Fi cells, what we saw is that they provide a high viability for both times, although revealing that silver skin coffee presented a higher viability. When these mycotoxins, which actually we saw it before, were exposed to the SHS Wi-Fi cells, this is the viability that we observe. So then we decided to try and to see what was the effect by performing pre-treatment and performing simultaneous treatment. So regarding the silver skin extract, also from this boiling water extract, we got this good and high viability of the undifferentiated neuroblastoma cell line. And so what we could conclude is that the SHS Wi-Fi cells exposed to berbericin and pretreated with boiling water silver skin coffee extract evidence a noticeable cytoprotection, and that viability did not decrease below 50% at 24 and 48 hours. Therefore, berbericin cytotoxicity in SHS Wi-Fi cells is alleviated when pretreatment with boiling water coffee silver skin extract occurs, and that boiling water extract, which actually is how we consume the coffee, despite having a high concentration of polyphenols and a usual way when consumers have coffee, it was enough. It has enough ability to decrease mycotoxins effects, protecting cell viability. In a further study that we are trying to analyze in garlic cloves, which are rich in organic sulfur compounds, we have plan to analyze these extracts in the same SHY5Y cell line and in the FG2 cells, and which has brought us with these studies and with the results that we expect to have also with the garlic extract is that there's the necessity that further bioaccessibility and viability studies of carotenoids, polyphenols from foods, and also the ones that more specifically come from goji berries and coffee, and their interactions with the obelisine could be useful for a better understanding of the cytoprotective effects of natural compounds and extracts and their use as ingredients to prevent toxic effects associated to mycotoxins. I would like to say again thank you for your attendance, and also I would like to mention that today is the Mediterranean Researchers Night, which actually it's going to allow to spread science around Europe specifically, but around the world and around the scientific community, which actually is in this webpage where you can find some of the activities that have been planned. And finally, I would like to thank you, the Laboratory of Toxicology, to all my colleagues, and also Professor Cristina Juan. Also, there was a collaboration from the University degli Studi di Perugia with Professor Domenico Montesano and Professors Gianni Sagratini and Giovanni Caprioli from Università di Camerino, both from Italy, which also were involved in this work. And with this spread of science and with this talk and webinar, we are also contributing to the SDG-4 to ensure an inclusive, which actually says to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all, which actually probably they need to be more emphasized and more efforts in this regard to have more access to the knowledge and education. But with this, we are very slight idea contributing to this. So thank you very much for your attendance and for your presence here today. Thank you. I don't know if, yes, I think we have a couple of minutes. We're going to be doing this by having the questions now. So after each talk, you have the option to ask or any question. So now is your turn. So it's Mohamed Fatih Abdallah. I am just wondering about the use of these natural products against the exposome, not one against the exposome, not one toxin. It could be. Thank you. Thank you for Jana Guy. Thank you for the presentation. Yeah. So the use of these natural compounds is more related to as a new ingredients that are being introduced and they're being to be used to the inclusion in the diet, more specifically as we are for sure coffee is consumed all over the world, and here also in Spain, but also in the Mediterranean zone, we consume also a lot of coffee. For sure in Italy, you also know. And so this is more contribution, how these natural compounds can contribute, can protect to this, to the effect of these also natural compounds, toxins present that can be present in food. So other effects associated to these polyphenols, there is research related to this, but we were more focused in knowing as this mycotoxin is starting to increase due to different climate changes and different conditions. I think the next presentation with the lecturer Oana Stanciu, you will get more indications, but it's a mycotoxin which is not legislated, which actually it constitutes or it belongs to the emerging mycotoxin. There's no legislation for it. It's starting to increase or to be more present in food. So how can be decreased? How can be influenced its effect through natural compounds? Is it possible to decrease its effects that are starting to be known, published, studied with these carotenoids and polyphenols, or what is happening? It's not being decreased. We have another question, and it's from Kisito Nishmiwe. It says, will you continue these studies in animal models? We haven't planned this. There's some studies actually with these natural compounds, but there's no studies with the being exposed animal models with this mycotoxin plus these polyphenols. So that could be a good and great idea, but has not been done yet. So that will be the next step, right? So once we see the effects in vitro, then we go in vivo to see if it's reproduced, and afterwards we see if it can have also and be even closer to the effects that can be produced or can be transformed to humans. There's another, okay, there's Timothy Jenkins. Thank you for your talk. Have you tested any of the protective effects in vivo? So as I already said, so we haven't, but yeah, that could be also a further step for the study. I can see many promising results. Thank you, Maisabel Mahmoud. And then also, do you believe that increased antioxidant levels via coffee concentration are sufficient to neutralize acute toxicity, or will other therapeutics be needed as well? So for having a good, and we've been what we've been testing here, it's the amounts that how you will be consuming goji berries. So we did an estimation that you don't eat more than 7 grams of goji berries. Is an estimation, actually, because how it is introduced, unless you like them and you eat them like very frequently, but actually how these goji berries have been introduced in the diet is more combined with cereals, combined with other products. So we did an estimation that actually with 7 grams of goji berries is the direct consumption that you can have. However, for coffee, it's more variable, because you can be a high coffee drinker or lower. But actually, what we were assigning, especially for the spent coffee, it was the approximate amount that you can get from 1 cup of coffee. For silver skin, this is more it will be that upcycling use that it will have, so we cannot have an estimation. But because of what you were asking regarding the consumption, so for the goji berries is the logical amount that you will eat nowadays with the goji berries, and with the coffee it corresponds to 1 cup of coffee. So yeah, maybe to have better effects from the goji berries, more consumption will be needed, but for coffee it can have other effects. And not only that, because polyphenols and carotenoids come also, at least from the point of view of the Mediterranean diet, it comes from other food, from other veggies and other fruits. So all this consumption, all this exposure to these compounds, we're having it in a normal diet, we're having it constantly. So other therapeutics will be needed as well. I think that it depends what's the effect that we're trying to reach, but to have a good or a benefit effect at neuronal or intestinal level. So I will say it's giving some hints, it's giving some protection, and also it's going to depend a lot in what's the amount of the mycotoxin of that contaminant present in food. So it's more. I'm sorry, I couldn't give an answer like more precise or more direct. I think it's several factors to be considered, so that's why. I hope I answer you. Thank you. Thanks. I don't know. I think we don't have more time for questions. Otherwise, at the end, it depends on how we go with the time. But at the end of the talk of the webinar, there may be a couple of minutes to, in case that you have some questions that you couldn't do now. Okay. Okay, so I think we can go for the next presentation, which actually it's the turn of Oana Stanciu. Dr. Oana is a lecturer of rheumatology, hygiene, and nutrition at Iliu Hatiganu, sorry for the pronunciation, from the University of Medicine and Pharmacy in Cluj-Napoca in Romania, in the Faculty of Pharmacy. She followed a master's degree in drug and environmental toxicology. She holds an international co-supervised PhD degree in pharmacy and food science at the University of Cluj-Napoca and the University of Valencia here in Spain, and defended her thesis with the academic title of summa cum laude. She obtained 2 doctoral research grants, contributing as Erasmus Plus Mobility Fellowships, and she received the Young Researcher Prize, Health, Nutrition, Food section at the first International Conference of Life Science and Technology for Well-being in Romania. Her research activities have been situated in the fields of food safety and nutrition. She has published a lot of data of emerging mycotoxins in cereals from Romania, and the first studies about the risk associated with the exposure to both regulated and unregulated fusarium mycotoxins. In the present, she is also a postdoc researcher of the Romanian Ministry of Education, working on the exposure assessment of Romanian population to multiple mycotoxins using human biomonitoring. She has published more than 30 abstracts in books of abstracts, and she's a co-author of various articles published in ISI Index International Journal. And as you can see, she's an expert also in mycotoxins, in evaluating this risk of exposure to mycotoxins, and more specifically for the Romanian population. So, Oana, the floor is yours.
Okay, thank you, Dr. Juan-García. I will share my presentation. Thank you, and hi, everybody. I will start my presentation today with a short question for you. Do you know that climate change can influence the development of fungi in plants? So I will present you today some results of my research studies developed in the last 5 years concerning the presence of various fusarium mycotoxins in wet and wet derivatives from Romania relative to weather conditions. So my presentation will start with a short introduction, and I will continue defending the objectives, presenting the general methodology and the results, followed by the conclusion. So, why mycotoxins and why wet? Cereals are caloric foods with beneficial effects for the human body, being the basis of the healthy food pyramid. Wheat, a member of the cereal family, is unique among the food grains due to its composition and its major contribution at the daily human diet and human health. Wet has many food usage forms, starting with the wet flour and continuing with bread, breakfast cereals, noodles, pasta, pastry, donuts, cakes, biscuits, and baby foods. In addition to the beneficial effects, grains can be contaminated by different types of contaminants, including seeds of the other crops, infected grains, defective grains, tainting materials, agricultural chemicals, foreign materials, insects, or animals. Of these, special attention is paid to mycotoxins, known as secondary metabolites produced by fungi, mostly belonging to the genus Aspergillus, Penicillium, and Fusarium. To date, more than 400 compounds have been classified as mycotoxins, this group of compounds being a heterogeneous class that can cause pathologic changes in other species. So, the formation of mycotoxins in crops and the transfer throughout the trophic chains to humans is stimulated by several factors. These factors of influence are related to the field mycotic flora, to the harvest period, also to the storage and processing houses mycotic flora. Finally, mycotoxins end up in food, and for this we can conclude that the presence of mycotoxins in food can be considered a human public health problem. So, from the mycotoxins, the most studied are aflatoxins, ochratoxin A, trichoterpenes, zearalenone, fumonisin, and patulin. The most important mycotoxins in wet are mainly fusarium toxins, such as deoxynivalenol, zearalenone, nivalenol, HT2 toxin, T2 toxin, and recently studied the emerging mycotoxins, particularly eniatine and beuvericin. Factors influencing the occurrence of diseases produced by fusarium species are linked to both substrate composition and environment conditions. Fungi can invade, colonize, and produce mycotoxins during either pre-harvest or post-harvest stages. There are many factors that influence the occurrence of mycotoxins in wet, including the plant substrate, the environmental and climatic factors like rainfall, relative air humidity, temperature, moisture availability, mechanical injury, insect or bird damage. Also, other factors are the topographic factors, the biological factors, the crop system and management factors, harvesting or the period of harvest, the storage, handling, and processing. Whereas there are many factors involved in mycotoxin infection, as you can see, climatic and topographic parameters possess the highest influence. The temperature, relative humidity, and moisture content of the grain are critical factors in fungal growth and also in mycotoxin production. In general, fungi grow at a temperature between 10 and 40.5 Celsius degree, also at above 70% relative humidity and a pH ranging from 4 to 8. Variations in climate parameters may lead to notable alterations in the quality of wet crops. Climate changes might influence crop yield and the degree to which the crops are contaminated with mycotoxins or would increase the development of fungi not identified previously within a given area. In the context of food safety, to protect the consumer from the harmful effects of these toxins, regulations for those mycotoxins with high biological implications have been established in more than 100 countries. Based on the toxicological data, international organizations such as the Food and Agriculture Organization or the European Food Safety Authority have established tolerable daily intake values for some mycotoxins, including the amount of deoxynivalenol and its acetylated derivatives, nivalenol, and the sum of P2 and HT2 toxin, and also for zearalenol. Moreover, for a wide variety of foods, maximum permitted levels of deoxynivalenol or zearalenol have been decided at European level, while only a recommendation has been issued for HT2 and T2 toxins. However, no values have been established for the emerging mycotoxins, and the official documents recommend that new studies on the analysis and incidence of these mycotoxins, the emerging mycotoxins in food, are needed. So, why we choose Romania? Romania is the largest country in the southeastern Europe with an agricultural land cover of 62% of the map. In Romania, wheat has a special contribution to traditional agriculture. Romania is the fifth biggest producer of wheat in the European Union after France, Germany, Poland, and Spain, with an annual production between 5 and 8 million of metric tons in the last years, more than half of it being exported to different countries around the world. Moreover, Romania has a temperate continental climate in transition, but in recent years, there have been various climate changes registered with negative effect expected also for the coming years. Despite Romania's high potential for wheat production, data on the occurrence of both legislated and non-legislated mycotoxins in wheat or wheat-based products from Romania are quite limited. Considering these aspects, the main objective of our investigations was to survey the natural presence of legislated and non-legislated Fusarium mycotoxins in wheat and wheat-based products from Romania. In order to achieve this main objective, some specific objectives have been proposed. First of all, to validate specific and sensitive methods for multi-mycotoxin quantitative and qualitative analysis in wheat and wheat-based matrices, to survey the natural occurrence of Fusarium mycotoxins in wheat and wheat-based products from Romania, to evaluate the correlation between Fusarium mycotoxin levels in Romanian wheat and the weather conditions, the most interesting part of this presentation, during different grain growing seasons, to assess also the influence of the agricultural practice on the occurrence and concentration levels of emerging mycotoxins in wheat, and finally, one of the objectives was to estimate the daily intake of Fusarium mycotoxins throughout wheat-based products consumption for the Romanian population. For this, we analyzed 15 mycotoxins included in our studies. We include 9 trichotoxins and also zearalenol and 5 emerging mycotoxins. In the category of emerging mycotoxins, including beauvericin and 4 eniatins, A, A1, B, and B1. Also, the products analyzed were products from Romania, including unprocessed wheat and wheat-based products such as flour, biscuits, bread, breakfast cereals, and pasta. In total, 349 samples were analyzed, including wet samples and wet-based products. The mycotoxins were evaluated using 2 different methods, using liquid chromatography coupled with mass spectrometry, and also the gas chromatography coupled with mass spectrometry. So, using these 2 analytical methods, the studies went throughout 6 stages. The first study included the evaluation of Fusarium mycotoxins in wheat and flour in Romania. So, In the first study, 14 mycotoxins were evaluated. In this first step, included 66 wet and flour samples from different counties of Romania. The mycotoxins were extracted by a solid liquid extraction, and the samples were stirred, centrifugated, filtered, after this evaporated, and redissolved in the day of the analysis. The residue was reconstituted with methanol water mixture to be analyzed after this by liquid chromatography tandem mass spectrometry. The analysis method was, in the first step, validated using the external standard technique by checking the linearity, the sensitivity, the recovery, the precision, and the matrix effect. A high sensitivity was noted for beauvericin and eniatin, with limits of detection below 12 micrograms per kilo, while a lower sensitivity with this method was observed for nivalenol and 50-acetyl deoxynivalenol. The recovery ranged between 60 and 133%, and the matrix effect between 64 and 130%. Within these results, it was considered that the method is satisfactory for routine analysis. Analytical results for our samples showed us that 73% of the samples presented detectable levels for deoxynivalenol, zearalenone, neosolaniol, and the 4-eniatins. 48 samples being positive for at least one mycotoxin mentioned before. The most common mycotoxin detected was the eniatin B, while the maximum concentrations found corresponded to deoxynivalenol and zearalenone. Moreover, 1 and 3 respectively wet samples exceeded the maximum concentrations allowed by European legislation for these two mycotoxins. Regarding the simultaneous presence of mycotoxins in wet, the most common was the concomitant presence of 3 mycotoxins, while in flour the most common was the contamination with 2 mycotoxins. Distributing the results of these tests by region, it was found that the highest concentrations of deoxynivalenol and zearalenone were recorded in Brașov County, a region known with a humid climate, and the highest incidences and concentrations of the 4-eniatins were recorded in Teleorman County, another region in the Danube Plain. This leads to the idea that there is a correlation between the susceptibility of the development of mycotoxins in wet, depending on the geographical region of cultivation. Thus, in the second study, the influence of climatic conditions on the development of emerging mycotoxins in wet during 2 consecutive years of cultivation was studied. For this, the incidence of beauvericin and the 4-eniatins in 97 wet samples from 2 different crop years and 3 different counties was evaluated using the previous validated method. Climatic parameters, meaning monthly and total rainfall, and also the temperature, were monitored in the wet cultivation areas by the Romanian National Meteorological Administration with an accuracy of 1 kilometer. It was demonstrated that the incidence of emerging mycotoxins in wet samples varied geographically. The results showed that for eniatin A and eniatin B, the highest average concentrations were found in Brașov County in samples grown in 2015, and the highest average concentrations of eniatin A1 and B1 were recorded in Teleorman County in the year before. Moreover, for eniatin A1 and eniatin B1, the correlation between the concentrations found and the year of culture was also demonstrated statistically by the univariate ANOVA test. So, analyzing the climatic data in the harvest regions, we concluded that high precipitation or high temperature during wet flowering, meaning the month of May, or before grain harvest, meaning the month of July, could increase eniatin occurrence, eniatin co-occurrence, and the mean concentrations of these mycotoxins. On the other hand, the multivariate analysis of the data performed by the principal component analysis highlighted that there is a specific influence of the climate for each region. Specifically, in Brasov County, the presence of eniatin B and eniatin B1 is more influenced by low temperature and precipitation in the month of May and June, or by high precipitation in July. In the Dâmbovița County, eniatins A and A1 are favored by high rainfall, and eniatins B and B1 by high temperatures. And at the end, for Teleorman County, the development of all eniatins has been found to be linked with low temperatures coupled with high rainfall in May, or by high temperatures in July coupled with low rainfall in April and June. In our first study, the influence of the agricultural practice on the development of emerging mycotoxins was evaluated. For this, the concentrations of the auvericin and the 4 eniatins in 133 wet samples of organically and conventionally grown were evaluated. Interestingly, the results show that the highest frequencies and concentrations for all the 4 eniatins included in the study were found in organic wet. In addition, the number of mycotoxins present simultaneously in each sample was assessed, and it was thus concluded that conventional agriculture is safer than organic farming in terms of the presence of emerging mycotoxins. Regarding the difference by varieties of the conventional wet classified, meaning included in one variety, for the most cultivated varieties in Romania, Boema, Dropia, and Glosa, incidences below 30% and averages below 4 micrograms per kilo were registered. In our fourth study, the correlation between the incidence of trichotechen and zearalenone in wet and the climatic parameters was evaluated. For this, 9 trichotechens and zearalenone were evaluated in 102 wet samples from the same harvest year, the samples being distributed over 5 large regions. The samples were extracted by solid-liquid extraction and further subjected to the derivatization process in order to be able to analyze the extract by the gas chromatography coupled with mass spectrometry in tandem. In the first step, the analytical method was validated with an improvement in sensitivity for the compounds with limits of quantification ranging from 1 microgram per kilo for deoxynivalenol to 20 micrograms per kilo for nivalenol and neosolanol. The recovery values ranged between 69 and 127%, and the matrix effect between 66 and 133%, thus demonstrating the possibility to use the method in the routine analysis, being sensitive, robust, reproducible, and rapid. Results for our samples showed that 67% of the samples presented detectable levels of at least 1 mycotoxin. Deoxynivalenol was the most frequently detected. 100% of the samples from, for example, the Northwest Romania being positive for this mycotoxin, followed by the incidences from central Romania and then North Muntenia. The highest mean concentrations for deoxynivalenol, their acetylated derivatives, HT2 toxin and zearalenone, were found also in the same region, this region named North Muntenia. Interestingly, the maximum levels of 5 mycotoxins were found in the same sample from this region, suggesting that there may be a close link between the concentrations of deoxynivalenol, its acetylated derivatives, and zearalenone. Moreover, 3 of the samples in this region exceeded the maximum permitted value of zearalenone in unprocessed weight. Analyzing the values of the 6 mycotoxins and the climatic parameters between April and July, it was found that there is a similar trend for the development of deoxynivalenol, HT2 toxin, and zearalenone in central Romania and northern Muntenia. Even if the ANOVA single factor test did not show a statistically significant correlation between mycotoxin content and the climatic parameters, probably due to the insufficient number of samples, some trend can be easily observed. A prolonged rainy weather during the earing phase, anthesis, dot formation, or filling, meaning from the beginning of May to the end of June, could favor high moisture of the wet crops, consequently influencing fungi development and mycotoxin production, particularly deoxynivalenol and zearalenone, and depending on various factors, also HT2 toxin. Moreover, it can be affirmed that the quantity of rainfall, especially during the month of May, possesses more capacity to influence mycotoxin content in wet, followed by the air relative humidity and air temperature. The last 2 studies have been focused to the wet-based products. The 5th study aimed to monitor the emerging mycotoxins in wet-based products and to evaluate the exposure assessment, evaluate the exposure for the Romanian population to these mycotoxins. The aim of the study was to evaluate the beauvericin and the eniatins in 111 wet-based products, including flour, pasta, biscuits, and breakfast cereals. In the first step, the extraction method was optimized, taking into account the complexity of the products analyzed. For this, 2 solid-liquid extractions were compared, one using rotatory shaker and another one using the ultraturax, and these 2 methods were compared also with a Quecher's technique for the extraction. The 3 methods were compared in terms of recovery and also in terms of matrix effect. Given the simultaneous extraction necessary for the 5 mycotoxins and also the need to analyze 4 different matrices at the same time, it was found that the optimal extraction method is the solid liquid extraction using the ultraturax. Subsequently, the method was validated, the quantification limits varying between 1 and 12 micrograms per kilo. The parameters of linearity, matrix effect, precision, and repeatability were within satisfactory limits to apply the method in the routine analysis. Evaluating the results, it was noted that for all the 4 matrices, the highest incidence correspond to eniatin B, but not exceeding 43%. The highest concentrations also belonged to eniatin B, the values found in pasta being clearly higher than those found in the other types of matrices. The concentrations found were used to estimate the daily intake of mycotoxins by the adult population in Romania, throughout the consumption of wet-based products. For this, a deterministic method was applied considering two scenarios, one of underestimation and another one of overestimation, and also considering the average weight of an adult of 70 kilos and the average consumption of wet products declared by the last data of FAUSTA. Since there is no tolerable average, since no tolerable daily intake value for emerging mycotoxins are in the literature, a hypothetical value for the TDI was proposed by the research group, established at 1,000 nanograms per kilo body weight per day. The results show that eniatin B is the emerging mycotoxin that contributes significantly to the emerging mycotoxin intake, and the approximate contribution of eniatins to the hypothetical TDI was only 8%. The last study aimed to evaluate the trichotechen and zearalenone in weight-based products from Romania and to assess the exposure for the Romanian population. In the study were included 9 trichotetechens and zearalenone evaluated in 181 wet-based products, including bread, flour, pasta, biscuits, and breakfast cereals. The method was validated after the extraction of the samples and the derivatization, and the validation of the method concluded that we can use the method for a routinary analysis. The limits of quantification range from 1 microgram per kilo for deoxynivalenol to 20 micrograms per kilo sample for nivalenol and neosolanol. Applying the validated method to our samples, only deoxynivalenol and 50-acetyl deoxynivalenol were detected. Deoxynivalenol being the mycotoxin with the highest incidence and also the highest concentrations. Regarding the distribution by product type, the highest concentrations were observed in flour. Moreover, 3 samples of flour, 2 samples of pasta, 3 samples of bread, and 1 sample of biscuits have been exceeded the maximum permitted values of deoxynivalenol in these types of products. Similar to the previous study, the estimated daily intake of trichotetechens and zearalenone was calculated throughout the consumption of wet-based products, noting that no tolerable intake value was exceeded. The highest intakes belongs to the amount between deoxynivalenol and its acetylated derivatives, covering 6 up to 69% of the tolerable intake. And with your permission, in the following, I will present the conclusion of our studies. First of all, the methods proposed based on solid-liquid extractions and coupled with liquid chromatography or gas chromatography analysis have been satisfactorily validated in order to analyze 9 trichotetechens, zearalenone, and 5 emerging mycotoxins in 6 types of different matrices: whole wet, flour, pasta, bread, breakfast cereals, and biscuits. Deoxynivalenol and emerging mycotoxins are the most frequent fusarium mycotoxins in wet and wet-based products for direct human consumption collected in Romania. Closer frequencies and levels of deoxynivalenol are present in both wet and wet-based products. The fact that similar levels of deoxynivalenol are observed for wet and wet products such as flour, pasta, bread, biscuits, and breakfast cereals too can be explained by the high transfer of deoxynivalenol throughout the food chain from unprocessed wet to its derivatives, and also due to the possible contribution to mycotoxin content of other ingredients in wet products for direct human consumption, or fungi development in packaging bags. The reduction of eniatin content during industrial processes such as baking or pasta elaboration is confirmed. A significant lower levels of emerging Fusarium mycotoxins are detected in wet-based products in comparing with the unprocessed wet levels. When mycotoxins co-occur in wet or in wet derivatives, 2 to 5 mycotoxins are present in the same sample, deoxynivalenol and its acetylated derivatives, or eniatin B and eniatin B1, being the frequent combinations found. The correlation between mycotoxin levels in wet and climatic and geographic parameters in the grain growing region is confirmed. Generally, extreme phenomena are favorable for fungi and mycotoxin development, and particularly high precipitation during May and July increase eniatin A1, eniatin B, and eniatin B1 occurrence and co-occurrence, while prolonged rainy weather during May and June favors deoxynivalenol, HT2 toxin, and zearalenone occurrence. On a long time consumption of wet and wet-based products, it can be stated for the moment that the use of conventional farm practices is safer than the organic practice. And estimates of daily intakes of Fusarium mycotoxins throughout wet-based products consumption by the Romanian adult population indicate that there is no remarkable risk for human health, but monitoring studies are permanently required in order to mitigate mycotoxin contents. And I want to mention that all of these results are the results of a collaboration between the University Iuliu Hațeganu from Cluj-Napoca, Romania, and the University of Valencia, Spain. And thank you for your attention.
Thank you, Dr. Stanciu. Thank you very much for your presentation, for all these data provided and work, and very well and very clearly presented. We have time for some questions. Is Timothy Jenkins asking? Thank you. Another interesting talk. How does mycotoxin diagnosis work in the field, and specifically, what kind of diagnostics tests are currently being used by farmers or regulatory authorities to establish safe mycotoxin levels? Is it only mass spec-based methods?
Well, thank you for the question. Routinely, there are used the ELISA tests by the authorities, not those methods using chromatography or mass spectrometry. In the laboratories, the most accessible are the ELISA tests for example, for the deoxynivalenol, for aflatoxins, for ochratoxins, or for other known mycotoxins. But it's true that for those mycotoxins non-legislated or non-regulated, it's not an easy method to detect these compounds, and in the laboratory normally are used those methods using chromatography.
Yep, I think it's. Yeah.
Thank you.
I don't know if there's any other question. Okay, so I might have a very short one. So you've been presenting all these mycotoxins, like in different counties of Romania with different levels. But I'm more interested, as you saw in my presentation before, in those that are not legislated. But actually, the incidence and the occurrence that you're showing in your presentation from those not legislated, it's important, it's considerable. So what do you think is the next step, or what is necessary to happen, or what it's I know that you've presented a lot of data from Romania, but what do you think it's more or it's needed to consider them already with levels of permission to have like a good regulation? What do you think is needed? What is lacking?
Well, thank you for your question. I think that the first step to have at least I don't know, maximum recommended levels in different foods should be to unify all the results about the emerging mycotoxins in Europe, and not all only in Europe, around the world, to see the levels using different analytical methods, and also unify these results with the toxicological data from the literature about the emerging mycotoxins, trying to extract for at least some recommendations about or regulations, if it would be possible, about these emerging mycotoxins, because not only in Romania, I also read in the literature that these emerging mycotoxins are frequently found in cereals and also in human products. So I think that the first step necessary is to unify all the results and to have a scientific opinion about these mycotoxins.
Okay, very good. I agree. Okay.
Thank you.
Thank you, Dr. Stanciu. We're going now next for the third presentation, which is from Dr. Liliana Liliana da Silva. She is a researcher at the Associate Laboratory LAQV Requinte from the Faculty of Pharmacy at the University of Coimbra in Portugal, developing research work in evaluating food and environmental contaminants. She has been involved in the determination of mycotoxins and also other contaminants in food and biological fluids, and evaluation of human exposure. Moreover, she investigates the occurrence of human pharmaceuticals in the environment and their bioaccumulation and metabolization by the aquatic biota. She received her PhD in 2008 from the Faculty of Pharmacy and the University of Coimbra in Portugal in nutrition and food chemistry. As part of his European PhD, she did during different periods trainings in the department of the preventive medicine, public health, food science, toxicology and forensic medicine at the Faculty of Pharmacy at the University of Valencia in Spain. She has published 1 book, 5 book chapters, as well as 35 articles publication in index international journals with a high impact factor in the areas of food science and technology, analytical chemistry and environmental science. For the total of 29 publications, and according to the Web of Science, she has an H index of 16 and a total of 745 citations. She has participated in several scientific projects funded by the Portuguese Fundação para a Ciência e Tecnologia, developing, optimizing, and applying analytical methodologies in the research areas that she develops. So the presentation that she is gonna take is titled Biomonitoring of Ochratoxin A in Children's Hearing. So Dr. Da Silva, the floor is yours. So thank you very much for being here too.
Thank you. Let me share my presentation. So good morning. I'd like to begin by thanking the opportunity to present my work entitled Biomonitoring of Ochratoxin A in Children's Urine, which was developed at LAQV Requinte at the Faculty of Pharmacy of the University of Coimbra. I'll start by introducing you to the Faculty of Pharmacy of Coimbra. It is located in the very recent Polo 3 the Health Sciences campus, as it is also the Faculty of Medicine and other health sciences research institutions. And this campus is just next to the Coimbra University Hospital. Our research institution is the Associated Laboratory of Green Chemistry that is part of the Network of Chemistry and Technology, REQINT. It was created in 1996, beginning with the Nova University of Lisbon and the University of Porto, and it spread to universities of Aveiro, Coimbra, Évora, and others. Now, moving on to the presentation itself, I will start by making an introduction to the topic. Then I will present the objectives, the materials and methods, the results and discussion, the conclusions. And I would like to say that this research was recently published in Food, Chemical and Technology. So if you want to look at this, it will be more detailed. So moving on to the introduction and just to remember a little bit, I'm the last one to talk, so some of the things were already said by the other persons, but the study of mycotoxins date back to 1962 at the time of the turkey X disease outbreak, when there were numerous birds died, essentially turkeys in England, that were related to the feed given to these animals. And this feed was produced from peanuts imported from Africa and Brazil, and it was found that they were contaminated with alpha toxins, mycotoxin produced by Aspergillus flavus, and one of the most toxic mycotoxins known. So since then, the study of these and other mycotoxins has increased, and mainly to understand the implications for animal and human health. So, as said before, mycotoxins are secondary fungal metabolites of low molecular weight, and so far more than 300 different mycotoxins are known. The most prevalent in food and also those with greatest toxicity are ochratoxins, aflatoxins, trichotoxins, zearalenone, and fumonizins. So in 1965, ochratoxin A was discovered in South Africa, whose main producers are Aspergillus ophrysseus, Aspergillus carbonarius, and Penicillium verrucosum. OTA can be found worldwide since it's producing fungi grow under very different conditions of humidity, pH, and temperature, as shown in the slide. So OTA has native fluorescence. It is slightly soluble in water, quite soluble in polar organic solvents, and soluble in sodium hydrogen carbonate solutions. And due to its good soluble stability at elevated temperatures, conventional food preparation processes are not sufficient to lead to its destruction. Degradation occurs at temperatures above 250 degrees Celsius for a few minutes, and it is also degradable by ultraviolet light. Structurally, it is formed by a hydroisocoumarine group linked to a phenylalanine group by an amide bond. Regarding its toxicokinetics, its absorption is species dependent. In humans, is about 93%. After absorption in humans, more than 99% binds to plasma proteins. That translates into an half-life of about 35 days. Its tissue distribution is also species dependent, being the kidneys and liver the major target organs. And as for excretion, there are few studies on this issue, but and there is also some controversy in their conclusions, but the fecal excretion is favored to renal excretion. However, there is enterohepatic circulation being subsequently released into the small intestine, where it is reabsorbed back into circulation and subsequently returned to the liver. Now, regarding human effects, and being the kidneys one of the major target organs, it is epidemiologically associated with the nephrotoxic Balkan endemic nephropathy. It has been classified by the ARC as possible carcinogenic to humans, and it is also considered as hepatotoxic, neurotoxic, and teratogenic. Recently, EFSA has published a scientific opinion on public health risks related to the presence of OTA in food, since new data have come available since the last assessment in 2006 that suggests that OTA can be genotoxic by directly damaging the DNA. So experts also confirm that it can be carcinogenic to the kidneys. So experts have now used a more conservative approach by calculating a margin of exposure and concluded that there is a health concern more for most consumers groups. This is a tool used by risk assessors to consider possible safety concerns arising from the presence in food and also in feed, of course, of substances which are both genotoxic and carcinogenic. In its previous opinion, EFSA established a tolerable weekly intake, a TWI, based on toxicity and carcinogenicity to the kidney that was considered in the present study. So a whole chain of events such as biological and environmental factors, harvesting, storage and distribution, process and also the processment led Food and Agriculture Organization to estimate that 25% of all agriculture products produced in the world are contaminated with some mycotoxin. They exist in almost all raw materials for foodstuffs, especially cereals and derivatives, ending up contaminating animals and also humans. Well, regarding children, OTA poses a serious threat to public health, in particular infants and children, considered to be more susceptible to different toxins than adults because of factors such as their lower body weight, their higher metabolic rate, their lower ability to detoxify, and their incomplete development of some organs and tissues. This explains why legislation always protects more this age range. As can be observed in this table, cereal-based foods and baby foods for infants and young children have the lowest maximum allowed levels. In this case, for OTA, 0.5 micrograms per kilogram. Well, the biggest obstacle to evaluate exposure and perform a reliable risk assessment is the lack of information on human exposure to chemical contaminants. The evaluation of the estimated daily intake based on food contamination and consumption data may be useful in a first approach. However, biomonitoring through the analysis of different biological matrices can reflect the effective exposure and account for variations, for instance, food contamination levels, food consumption, and food preparation techniques. So, biomonitoring allows the exposure of each individual to be measured by its determination or its metabolites, and also biomarkers of effect on biological fluids or tissues. Biomonitoring of OTA is favored by its long half-life of the mycotoxin in the body, resulting from an extensive reabsorption, affinities of the toxin for plasma proteins, and also the possibility of enteropathic recirculation, as I said before, that additionally retain OTA in the circulation. Despite resulting in relatively higher OTA blood levels, urinary OTA exposure biomarker is a non-invasive alternative, increasingly important with the advent of some more sensible and accurate methodologies of analysis. Contrarily to blood-based biomarkers compromised by the steady state concentration, OTA in urine proved to correlate more closely with the level of consumption among the general population. In this regard, the European Commission recently launched a notice for the initiative on human biomonitoring under the H2020 Societal Challenge on Health, Demographic Change and Well-being, with the aim of creating a joint European program for scientific monitoring and evaluation of human exposure to chemicals and potential health impacts. The goals of the present work were to first assess the exposure of Portuguese children to OTA through the biomonitoring of urine, and also calculate the probable daily intake to better characterize the health risk of this population. So regarding the sampling, we collected 85 urine samples from healthy children from the central zone of Portugal. They were first morning urine samples. 41 were males and 44 were females, aging between 2 and 13 years old. And this sampling occurred between July of 2018 and March of 2019. The anthropometric data of the sampled population, namely age, height, and weight, is characterized in the table. An informed and written consent was obtained from all the participants, namely their parents, of course, that also filled a short questionnaire providing basic information such as age, body weight, height, and a food frequency questionnaire. The study was performed in accordance to the Declaration of Helsinki. Regarding the experimental procedure, the analytical methodology was based on an immunoaffinity cleanup, followed by LCFD analysis. The concentration of creatinine in each urine sample was used to correct the differences in dilution between individual and excretion rates. The urinary creatinine level was measured through an in-house colorimetric method based on the principle of Jeff's reaction. And in summary, picric acid was reacted with sodium hydroxide to form an alkaline picrate, and this alkaline crate was then reacted with the diluted urine to form a creatinine precrate, and the absorption alteration ratio was analyzed and proportional to a creatinine concentration in the sample. The risk assessment was performed comparing the probably dietary intake, the PDI of OTA, with its tolerable daily intake derived from the TWI established by EFSA in 2006. Of course, exceeding the TDI can imply a possible health risk for the population in study, and the PDI was calculating using the OTA urinary concentrations and compared to the TDI of 0.017 micrograms per kilogram of body weight per day. The PDI was calculated using the equation shown in the slide, where C is the urinary OTA concentration not corrected for creatinine in nanograms per liter. V, it's the daily urine production of children, and we consider 1 liter. W is the body weight reported in the questionnaire in kilograms, and E is the urinary excretion ratio of OTA. We consider two values, as you'll see later on the excretion, 50% and 2.6%. Of course, we performed statistical analysis, and we use the GraphPad software to test whether the datasets were of Gaussian distribution. We use D'Agostino-Pearson normally test, and since most of the datasets were not normally distributed with non-homogeneous variances, non-parametric tests were applied. For the comparison between OTA concentration levels and the anthropometric data, Kruskal-Wallis tests with Duns-Boss test and main weakness tests were also used. The statistical significance level was set to under 0.05. For analytical validation, different performance parameters were evaluated, such as linearity, detection and quantification limits, accuracy and precisions, and the results were adequate. Recovery tests were performed to determine the accuracy and precision of the method by using blanks and also spiked samples at 3 spiking levels, 0.02, 0.08, and 0.50 nanograms per milliliter. And for each fortification level, 3 replicates were performed in 3 different days. Recovery values ranged between 90.06 and 97.84 for 0.50 and 0.08 nanograms per milliliter, respectively. Precision was evaluated through the relative standard deviation of intraday and interday repeatability. The intraday repeatability varied from 0.97% and 7.006% for levels at 0.08 and 0.50 nanograms per milliliter, respectively, and the interday repeatability oscillated between 6.83% and 10.58% for 0.15 and 0.08 nanograms per milliliter. Adapting the regulation of the European Commission, the 401 of 2006, the values found for both the accuracy as to the precision respect the established requirements. Regarding the frequency and occurrence results, overall from the 85 analyzed samples, 79, meaning 92.94% were found positive. From these, 36 samples presented OTA levels above the limit of quantification. The average OTA concentration level was of 0.02 nanograms per milliliter, meaning 29.41 nanograms per gram of creatinine, with a maximum value of 0.052 nanograms per milliliter, meaning 114.45 nanograms per gram of creatinine. Regarding gender, similar values were observed for males and females, both for incidence and average OTA levels that were of 0.02 and 0.018 nanograms per milligram respectively. As for age, higher OTA frequencies were found in the ranges of the 90 to 140 and 14 centimeters, and the range of 139 to 161 centimeters, with this last range presenting higher mean levels. Finally, regarding weight, higher mean levels were found in the mid-range, the range of 25 to 35 kilograms, with 0.022 nanograms per milliliter of OTA. Nonetheless, no statistical differences were found between the OTA contamination levels, either in the nanogram per milliliter of urine or the nanogram per gram of creatinine, and the anthropometric data considered. Therefore, OTA urine content were independent of age, height, and weight. Similarly, no statistical differences were observed between OTA contamination levels and dietary habits. When comparing with other studies regarding children, there are not many, but in a study conducted in Belgium, the results showed that 51% of the children's urine samples were contaminated with OTA with a mean level of 0.079 nanograms per milliliter and a maximum of 3.68 nanograms per milliliter. The levels of OTA were also determined in children's urine from Sierra Leone, and OTA was found in the urine of 21% of male samples and 31% of female samples, ranging from 0.07 to 148 nanograms per milliliter. Finally, a study conducted in Cameroon to investigate mycotoxin exposure in children from high mycotoxin contamination regions showed that OTA was present in 32% of the samples, ranging between 0.04 and 2.4 nanograms per milliliter. Well, in comparison with these studies, although in the present study the frequency of OTA was higher than those found in the literature, in general, the maximum and average contents were significantly lower. Now, regarding adult population, most studies have been performed in adults. And regarding European data, in urine samples from Swedish adults, 51% of the samples were contaminated with OTA in average levels of 0.9 nanograms per milliliter. In another study in Belgium, OTA was found in 35% of the adult samples, ranging between 0.0027 and 0.368 nanograms per milliliter. Another study from southern Italy in 52 volunteers, OTA was found in mean levels of 0.144 nanograms per liter. And in a group of 72 adult inhabitants of Lleida in Spain, the OTA levels range from 0.057 to 0.562 nanograms per milliliter. Well, in Portugal, several studies have already been performed, but in the last one, Duarte et al. 2012, found that overall in winter and summer, samples of the central zone, that in summer samples of the central zone of Portugal, an OTA incidence ranging between 83.3% and 100%, and an average level varying between 0.01 and 0.013 nanograms per milliliter. Well, one can verify that the levels found within adults from the central zone were approximately half of those found in the present study with children. These results might be explained by the fact that children's body weight is relatively lower and they are large consumers of certain types of foods, such as cereals, resulting in a higher exposure rate. Finally, on what concerns the PDA and the risk calculation, it is noticeable the lack of information on the toxikinetics of this mycotoxin, and this is not an emergent toxin, so it is a well-studied mycotoxin, and namely regarding its excretion rates, there is a lot of controversy, and as I mentioned before, the uncertainty in calculating dietary intake of OTA based on the urinary levels is very high because of the complicated relationship between OTA and excretion in urine. While some authors consider an excretion rate of 2.6% based on an exposure study performed with piglets, others consider an excretion rate of 50% based on the toxikinetics profile of OTA following ingestion of a labeled OTA by one human volunteer. So in the present study, we decided to adopt both approaches, taken into account to assess the PDA and risk. So the risk was calculated as the percentage of the PDI exceeding the established TDI value, 0.017 micrograms per kilogram of body weight per day. And these results should be considered as rough estimates rather than accurate exposure assessments, but they give a valuable insight to the exposure situation of the investigated populations. Also, two PDI evaluations were carried out based on two different scenarios. The first one, the mean contamination levels of OTA were taken into consideration, while in the second one, the worst case scenario was observed using the highest concentration found. And as seen in the table, when considering the highest excretion rate, 50%, the calculated PDI is considerably lower than the TDI. In fact, considering the OTA average contamination of the samples, the scenario 1, the PDI is 10 times lower than the TDI. It was 10%. This percentage increases to about 26% when the worst case scenario is considered. However, these figures greatly increase when the excretion rate considered is 2.6%. In this case, the PDI value of the first scenario is 0.033 micrograms per kilo per body weight per day. That exceeds the TDI in 94%. The ratio PDI-TDI reaches a value of 500% when the worst case scenario is considered. In conclusion, the occurrence of OTA in human urine has been reported in several studies around the world. However, studies in children are still very scarce, although they're higher vulnerability. Overall, from the 85 analyzed samples, 79 were found positive. The average OTA concentration level was of 0.02 nanograms per liter, with a maximum value of 0.052 nanograms per milliliter. No statistical difference were found between the OTA contamination levels, the anthropometric data, and dietary habits considered. Thus, considering this population, variations in OTA urine content were independent of age, height, weight, and diet. Urine biomonitoring is not invasive and has been shown to be a good marker for OTA exposure in children, and depending on the excretion rate considered for the PDA calculation and the risk assessment, the average OTA contamination varies from 10 to 194%, which indicates a potential concern and demonstrates the need for better and robust estimates of urinary OTA excretions. Before ending, I'd like to acknowledge Fundação para a Ciência e Tecnologia for the financial support, and also my teams and colleagues from the Faculty Pharmacy of Coimbra that collaborated in this study. So thank you for your attention, and if you have any questions, please.
Okay, thank you very much, Dr. Da Silva. It was a very nice presentation, very well compared with other studies. So there's a good contrast of information and data, which actually it's very good. It's very nice. I'm gonna share one slide compare here and here. Okay, and I would like to okay, so and I would like to have now the time for questions regarding your presentation. I don't know if there's any someone. Okay. So, as I said before, we have a couple of questions for the presentation of Dr. Stanciu, but now we're gonna follow with the questions from Dr. Da Silva. So it's Bojan Sarkang who says, thank you for a very nice presentation and detailed explanation of the metabolism and excretion rates. What are your opinions on other OTA biomarkers such as 2R ochratoxins A or OT alpha, OT alpha glucuronides? Can you use them for biomonitoring?
That will be the next step of the study. But when analyzing the metabolites of OTA, we cannot just use an LCFD methodology. So we have to use more sensitive methodologies like mass spectrometry, tandem mass spectrometry, to be able to separate all these compounds.
Okay, very good, thank you. But I think she was answered already. I had a short question that actually bring my attention to it, and it was when you were comparing the data with other studies and in different countries. So what I saw is that when you were presenting that table, it says that in the Italian population, the Italian population were the one presented the highest levels, like the highest higher levels of these compounds. So do you know why is it related to? What is it related to, or why is it happening? Because we're talking about, it said 0.006 to 2.129. So those were very high levels. Is any consideration in that study? Is there any reason that you think of, or?
I think that it might be explained by their consumption patterns. We know that Italians eat a lot of cereals in pasta, and and children also eat that. So I think it's explained by the consumption patterns of the different populations. Yes.
That's very good. No, it's actually true that Italians eat a lot of pasta and cereals based in pasta. So, but actually it's good that it's correlated, but it brings my attention. But it's also good to.
It's good to eat cereals, but not so much.
No, not so much. That's why we need to have a varied diet. No?
Yeah, balanced one.
Exactly. Okay. I don't know if there's any other question. Just to close the talk of Dr. Da Silva. I don't see anything in the chat. Okay. Okay, good. So thank you very much. We're going now because I didn't realize that we had 2 questions for Dr. Stanciu in the chat. So we're gonna deal with them. Yeah, Dr. Stanciu is also connected and available. So it is from Cindy Sun that says that what's the best way to reduce the climate effect of on mycotoxins production? What's the best way to reduce the climate effect?
Well, thank you for the question. Probably it's not only one method to reduce the influence of the climate changes to the mycotoxin production. Probably we must to include some strategies. First of all, to reduce the climate changes, starting with with us, and after this, trying to regulate mycotoxins, meaning check the levels of mycotoxins in food and also in raw material. And after this, trying to mitigate the mycotoxins using methods starting from the harvest to the storage, and after this during the process, the industrial process, to obtain human food for direct human.
Okay, I think it's enough with the answer. Thank you. And then there's another question from Bruna Filipa Carvas, who says, did you find fumonisins in wet or wet-based products from Romania?
Well, we didn't include fumonisins in our studies. First of all, because normally in wet, the concentrations of fumonisins are not so high, and normally fumonisins are found at higher concentrations in corn. So consequently, in our studies, we didn't analyze fumonisins. I check during my studies about fumonisins in wet. And in Romania are some studies published 5 or 6 years ago about fumonisins using ELISA methods. But in our studies, we don't have results for fumonisins.
Okay.
Thank you.
Okay. Thank you very much, Dr. Stanciu. So I think all questions are answered, unless that somebody else wants to do any. Okay, so with this, then we have concluded the webinar, but I would like to give and to express my gratitude for being for having this possible. For sure, from the organizers, from the NDPI Toxins, Cindy Sun, Bonnie Yang, and Karin Hisler, and for sure the presenters, the speakers in this webinar, Dr. Stanciu, Dr. Da Silva, and Dr. Juan. And so as you've seen in this webinar, and I tried to summarize some of these SDG, which actually have been somehow involved and give some hints of them in the presentation. I probably give more specifically the details or mentioning them, but also with the presentations of Dr. Stanciu and Dr. Da Silva, they also give few things related to this SDG. And I wanted to put it in this slide with number 2, number 4, number 12, number 13, and number 15. And for sure, I will say that in global, besides all these SDG goals that have been spread and proposed in the Agenda 2030, one of the things that we are all together involved for sure at this moment and with these webinars is for the one involving the quality education. And with all this being said, I would like to say again thank you, and you have a good day, and I hope you like it. And for sure, I also will like to give thanks right now how come the attendance in online. Thank you very much.
Thank you.
Thank you very much. Bye.
Thank you very much. Have a nice weekend.
Bye-bye.